good afternoon. We had some technical issues, sorry about that. It's sorted, so we can start. This session is about the security of web applications. And when building novel web applications as a developer, you will try to select cool technologies, the newest frameworks, and then you may expect like, these frameworks help me to improve the security of my application. But as a matter of fact, it's a hard work to make your applications more secure, and that's what we are going to talk about in this session. So my name is Theodoor Scholte, and I'm here with my colleague. I'm co-presenting this session together with Barbara Vieira. So who are we? We are both software security consultants at the Software Improvement Group. SIG is a European software quality consulting firm with offices in Amsterdam, the Netherlands, Copenhagen, Belgium, and Germany, and also in Athens we have an office. In our daily lives, we evaluate software systems, we measure them, we conduct source code reviews, design reviews. We look at different quality aspects like maintainability, security, performance, reliability, and we advise clients on how to improve software systems. And in our spare time, we both like to hack, and we are both from academia. We used to be security researchers in the past. But more important, we would like to know more about you. So who is here a developer using cool technologies like Spring Boot, AngularJS? I see already more hands, pretty cool. MongoDB, who is using NoSQL databases. Who's interested here in security? Who's concerned about security? Whoa, a lot of people. Oh, that's good that you're here today. And did you ever implement security features yourself, like authentication, authorization, access control? A few hands? Cool. And were you relying on frameworks for these, or did you all implement it yourself? Spring Security? Okay, good. So, as I mentioned before, we are experts in evaluating software systems, and SIG is using the ISO 25010 standard for software quality. This standard consists of different quality aspects like maintainability, reliability, performance, and security. And for each of these quality aspects, SIG operationalized a model which we use to structurally analyze a software system. So confidentiality, unfortunately, it's a bit hard to read, and integrity, non-repudiation, accountability, and authenticity are parts of this ISO 25010 standard for security. But you can't directly evaluate them on code and design level. So we did research and identified several system properties that allow you to look at the security aspects of a system. So one of them is secure data transport, another one is authorized access, input-output verification, secure data storage, evidence strength, user management. These are all security features, but also things we evaluate. And behind these system properties, there are checks that can be found in the industry standards, like the OWASP Application Security Verification Standard. And basically, we look at whether best practices in these standards have been applied in the software system, and what is the quality of the implementation. So we evaluate the presence and quality of security best practices in design and source code, and an evaluation typically results into a star rating from 1 to 5 stars. 1 star means none of your security best practices have been relevant and expected best practices have been implemented, and 5 stars means everything has been, you're doing a very great job. And this is very handy to have this, it's very useful to measure actually software security in this way, because if you measure things, you also know how good you are in things, and it also gives you a motivation to improve things. So if you score 1 star or 2 stars, then it's clear that in the next evaluation you have to do stuff to go to 3, 4, or 5 stars. So over the past couple of years, we evaluated a number of software systems, and this is actually an overview of our benchmark. So I collected all the evaluation data of all the systems we have analyzed in the past, and these are the average ratings for the different system properties. So you can actually see here 2 things, is that on average, software systems score below 3 stars in general for all different security system properties. And there are actually a few of them which are a bit outlying, which are, actually only score 2 stars. And today we'll focus on these 3 aspects: authorized access, so access control mechanisms; input and output verification, so how well can systems be prevented against input validation vulnerabilities and injection attacks; and secure data storage. So how do you make sure that the data you store in your databases are protected? So this is an architecture of a modern web application. You have an Angular front end with a model view and controller. You have a back end which consists of Spring Boot microservices, a REST API, and then MongoDB that is used to store state of your application. So let's first look at secure data storage. So what are the typical pitfalls and issues and challenges that arise when storing data in MongoDB securely? So MongoDB has been negatively in the security news in the past couple of years. So you have Krebs on Security, and well-known security journalists which reports that 35,000 MongoDB instances were exposed online. You have the number of leaking MongoDB databases are increasing from Shodan. Who is aware of these issues? Only a few. Good. Then some people learned today something. That's pretty cool. So what is Shodan? Shodan is actually the Google for hackers. So while Google indexes websites, Shodan indexes servers, operating systems. So you can use Shodan to search, for example, all SAP NetWeaver systems that are connected to the internet, or some kind of, if you know the manufacturer, the vendor, the model of an ICS, an industrial control system, or a SCADA system, you can find all kinds of industrial control systems that are connected on the internet. And of course that's a bad thing, because with ICS, factories and also very critical infrastructures are managed through ICS systems. But also MongoDB, and you can also search for MongoDB, and a search on MongoDB resulted in that more than 50,000 MongoDB database servers are exposed to the internet. And then you can also find out which IP addresses are listening for a MongoDB server, the amount of data. So this is, unfortunately you can't see it, but this database contains 160 megabytes of MongoDB data. and the countries where they're located. So you can pretty get a lot of details from this website. And actually then you can just, with your MongoDB client, you can actually just log on these MongoDB instances. And typically you can, since authentication and authorization are disabled by default, you can access the data. So how does this come actually? So one of, if you install MongoDB, by default, there are a number of configuration settings that are enabled or disabled by default. And one of the things is that MongoDB listens by default on all network interfaces. So also the ones that are publicly accessible. So there's one exception for certain Linux packages like Debian and RPM packages. The default configuration is that MongoDB only listens on the local host, so it can only accept connections from the database server itself. And another thing is actually that authentication and access control are disabled by default in the default configuration. So you don't need to provide a username or password to access the data in your MongoDB instance, which is, on the one hand, very convenient, but also very insecure, right? And then you also have MongoDB also has a built-in web server, which allows you to get all kinds of information from running the MongoDB instance. So let's go to a demo now where I show how that works. So you have here the configuration option called no HTTP interface. It's set on false, and then you have you can access actually the web server using port 28017, and you get all kinds of detailed technical information about your MongoDB instance. And then that allows a hacker to get more information and yeah, have more success in an attack. So some recommendations on how to fix the MongoDB configuration. Yeah, ensure that only trusted hosts do have access to the MongoDB network interfaces. So define explicitly on which network interfaces MongoDB listens on. Limit the network, enable firewall rules, so you only allow access to from hosts that you trust. So for example, the host on which the web server, your web application is running on. Disable the MongoDB's HTTP server, so set this no HTTP interface option to true. And enable authentication and role-based access control, ideally using certificates, and yeah, enable access control. Actually, these are all very simple things, but yeah, a lot of people in this world unfortunately fail to do so because more than 50,000 MongoDB instances are exposed online. So another issue with MongoDB is input and output verification. So let's focus on that one. So with traditional web applications, we're making use of SQL databases, and quite some web applications were then vulnerable to so-called injection attacks. So you could do an SQL injection, craft some malicious input, inject it in your web application, and then the database server would execute the query that was modified by the attacker. Well, with NoSQL, it doesn't mean that you don't have injection attacks that are possible. However, it's a bit more difficult and a bit more tricky. So the MongoDB driver of Java provides a secure way of accessing the MongoDB database server. Provides an API to assemble secure BSON queries, which separates user input from queries, and And then if you make use of this API, these injection attacks are not possible anymore. However, there's one exception to this rule, and that's when you use specialized query operators such as the where. This operator allows the execution of unserialized JavaScript and JSON expressions. And this slide shows a query on a collection called users, where you have a JavaScript expression. A user name is compared to some username provided as user input. The password is also compared to some user input, and so it's actually done through string concatenation. And then, as an attacker, actually, this is part of this is a query part of a login process. It compares the username and password, so it checks whether the user's collection contains a document with a particular username having a particular value and a password containing having a particular value. And then an attacker may craft some malicious input that would completely bypass your authentication system, because you give just a password, a sample password, and then you modify the query in a way that you evaluate 1 to 1, or a particular string is always equal to another particular string, and yeah, that always evaluates to true. So in that way, you bypass the authentication mechanism. So let's go to this demo, which show you this in more detail. So this is a very simple authentication page. Well, I provide the username Theodoor and test, and yeah, that's not the right password, so it fails. Behind this authentication page, there's a MongoDB query where the query is concatenated with user input, the username and password from the login form. And instead of providing a decent password, I provide a malicious payload. I provide a password, an OR, and 1 is 1, which always evaluates to true, of course. I put it in there, submit it. So now I'm in the debugging mode of Eclipse. The username field is just Theodoor. The password has this this malicious payload, the OR. So the password is T-OR is 1 is 1, as shown in this query, and this one evaluates always to true. So then so just the sample password, which is of course wrong, but then the OR, and 1 is 1, which evaluates to true. So if I continue, then I'm in the system. So how to fix injection with MongoDB? Well, do not use user input in particular sensitive query operators, with particular sensitive query operators such as the where operator. Always perform input validation and standardize input for characters that have a special meaning in JSON and JavaScript. So the tick, the quote, the slash, backslash, a semicolon, and other characters. So now Barbara is going to talk about access control.
Hello. 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 Good morning. I think I cannot hear you. Can you hear me very well? Okay. So, good morning. I think you are a bit asleep, so just wake a bit. So I'm going to talk about access control, authorized access, how we call it, in the SIG model. And I'm going to ask you something first. Who has had problem with access control in your applications? Who is a developer first? And who had access control problems already? Be honest. They are not recording your hands, so you can be honest. And how severe were these problems? Because if an attacker can bypass your access control policies, your access control checkers, they can do whatever they want in your system. How severe were these things? High, low, medium? You can be honest. They are not gonna recording your answers. So, and can you tell me the reason why this happened? It's because you didn't put a filter. It's because you forgot to filter out a public method. No answers. So I think that's kind of a severe problem if you cannot have access to your data, especially if you have password stored or any client's data stored. So the problem we see often is that access control happens not in the back end of the applications, but in the front end. So I don't know if you can actually see the code that is written there, but this is an HTML view and what it says there is, if not authenticated, then show something. And in the backend, so this view shows loads something from the backend. And in the backend, you have this REST controller that just gives some data that reads from the database. So this is easy to bypass because you can easily call directly the REST API. So you can get all your data. And what you should always do, if you, for instance, in Spring Boot, is to use a filter that will filter out all the requests that are not authorized to access that data. So this is an application. It's a demo application we developed on purpose for this presentation, and I cannot start it. I don't know exactly why. Which is online on GitHub, so you can check it. And what it does is, so you are not logged in. So you log in into the application, and now you can see the data. So it loads some data from the database. And if I log out, so I should not be able to have access to this data, right? But let's see what happens in the code. So you can easily inspect the code, the views, right? Because this is HTML code that's loaded on your browser. So if you look at the view, you believe me, or you can check online that there's different behavior to be shown when the user is authenticated or not. So there's a flag on the browser saying if the user is authenticated, then you can log in. If not, you cannot. If the user is authenticated, I show something. If the user is not authenticated, I show something else. And then it loads something. The controller, the Angular controller associated to this view, gets some data from the backend. And this is the REST controller I showed in the slide. And as you can see, there's no filter to prevent any access from the user to this data. So you can easily bypass the REST calls, the checks on the view, and directly call the REST API. So how many of you have done an implementation like this? Okay. You're not being very interactive today. So what do we always recommend when you implement authorization is that your authorization mechanism, your access control should be centralized. So you should not try to implement weird and confusing logic for access control within your methods, because that's not going to scale. And once you add a new functionality, you will have a problem. So that's why we always recommend centralize your authorization. And the thing we often see is applications allow you to have access to everything and then deny access to certain things. And it should be exactly the other way around. So first, you should deny, so no one has access to anything, and grant whenever the user has actually access policies to access some resource. The other thing is you should always have authorization checks in all your public methods. If you are ever calling, in this case, specific case, we are talking about REST services, and all the public methods should have access control policies, so should have annotations. Another thing that is more refined that prevents you some kind of attacks like indirect object references, data level authorization. So if you have authorization checks for each data row you have in the database, then you have a more fine-grained access control. And of course, checking the policies once when the user logs in is not enough. So you always have to repeat your checks. So a bit zooming in now again on output escaping on the browser side. How many of you were vulnerable to cross-site scripting injection, cross-site scripting vulnerabilities lately? Everyone is safe. I don't believe you. I'm sure I can hack your website. So this is to show you how easy it is to actually perform a cross-site scripting vulnerability or attack if you are vulnerable. So this is jQuery. So jQuery, this is a JavaScript code using the jQuery library, and it reads some. It posts some data in the backend, and the Java controller associated to it just stores the data in the database. So this is because jQuery doesn't have any mechanism to escape the input. Then if you introduce a my cookie value, it can do anything, whatever I want. And it's stored in the database, and then it's loaded again. So you can load it from the database, and then you see what happens. So this vulnerability can be introduced in your application by an attacker, and then it will be spread to all your users. And then it can do whatever the attacker wants. So it can redirect the session ID, the cookie, to the attacker's website. And then it can be used to bypass your application. So this is the corresponding code. And then this is a jQuery code. So this is a code that is on the slide. I don't think you can actually see it very well. Sorry for that. But you can see it online. So the problem here is, if you look at the code reads the data and checks whether it should escape the data or not. So there's a way of preventing this using jQuery also. So if you escape the data on the back end and you don't store the data as the user input, then you prevent this kind of vulnerabilities. But in this case, this escaping, it's turned off just for the demo purposes. But there's a way of, so the recommendation here is that you should always do this in the back end and not in the front end. Even having Angular escaping certain user input, you should never rely on the front end. Okay, so this is the Angular part where you see that the JavaScript code is not executed. And I'm going to skip the coding part because you cannot see it. And you can actually check it online. So, as I said, Angular prevents you some against some attacks in certain way. But because Angular developers decided to remove expression sandbox last September, there are certain methods that are actually vulnerable. So it's actually possible to do a cross-site scripting attack in an Angular application. And I would like to ask you, how many of you are developers of an Angular application? And how many of you are certain that you don't have a cross-site scripting attack or are not vulnerable to cross-site scripting? So these kind of attacks are actually very easy to do. And you can perform them because there are certain functions that if you don't validate the user input, the Angular functions, then you can easily load some malicious content. So I'm almost finished. So in this case, this is a filter, and then you can sort this table by whatever you want. So you can select here, you can put here, it accepts here user input. And because of that, if I input some, like the last name, so it's going to be ordered by the last name. But I can also do a cross-site scripting attack. And what it's going to do, so this is, again, showing the cookie. It will perform and execute the JavaScript. So things that you should always do or you should never do is to disable the sanitization that Angular provides. So Angular is already vulnerable. You want to validate all user input, but you don't want to disable the sanity checks that are already there. So we should never do that. And we've seen that happening. And developers sometimes don't know why they did it. So the other thing is, of course, you should never, ever trust the data from your user, because it's going to always have, it's going to always be tainted. And don't forget that, yes, you have type checking, but type checking doesn't prevent your attackers from introducing malicious content in strings. So we only showed some examples of things you can do and how you should prevent them. But as Theodoor said in the beginning, the systems we have seen, and we have seen a lot of systems, don't rate more than 3 stars. And this means that most of the systems don't implement the best practices. So if you look at this rating, this means that there's a lot to be done. And the question we always raise is, where is the problem? How can we help developers? How can we help the world to actually make better and secure software? So if you are developing secure software, then you are familiar with this lifecycle, where you should always train. So you should always receive secure coding training. You should always define your secure requirements, your security requirements. You should have a design phase, implement the requirements, test and verify that the application has the requirements implemented and deployed. So what goes wrong in this life cycle is, first, how many of you are trained for security? How many of you had secure training codes? And then the problem starts with training, but then you don't define the requirements. So the thing you have from your product owner is, so my software has to be secure. And what does that mean? So then, yeah, it needs to be secure. But if you don't specify what secure means in your case, then you will have a lot of flaws. And again, you continue. You don't identify. You fail identifying the threats, and you don't implement the countermeasures. And then, in the end, you implement your functionality, and you say, my system has to be secure now. So what you do is you implement security as an overlay, and not by design, as it should be from the beginning. So then you fail to test your application, right? So we barely see unit tests for security. And this is, and also, it's very, we don't also see static analysis tools being used a lot or or integrated in the development pipeline. And then sometimes you do pen testing, and there's a huge amount of flaws you have to fix. And then, of course, you fail to deploy, or you delay the go live, or when you go live, you just have an attack. So how do we see these things? So yeah, training is very important, and it's very hard to understand how security should be implemented in the correct way. But it's because security is a difficult concept. Even with training, developers have a difficulty in trying to implement the best practices. So they try to do their best, but still not enough. And because the requirements are not defined, then you can never implement them properly. Oops. The other thing is, when you don't know something, what do? You just Google it, right? And there's a lot of forums, a lot of blog posts saying how you should implement something. The thing we've noticed is that most of these examples are insecure, especially the ones that involve usage of crypto libraries. And it's a huge problem having insecure examples that are going to be copy-pasted to your application running, and they will introduce flaws. It's also hard for forums or blog posts to actually understand what is wrong and what is right. So the other problem we also see is that many frameworks and libraries that are out there have defaults that are not secure by default. So we've seen a lot of libraries using SHA-1, for example, has a default hash algorithm. And I don't know if you are aware or not, but SHA-1 is not being recommended for many, many years. And currently, there's an attack for SHA-1. So having libraries, using only the defaults of the libraries without understanding the libraries, without reading the documentation of the libraries, leads, of course, to insecure applications. And many systems are not really maintainable. So in the picture, you see two of our colleagues looking at a function. This is a function that was printed out in paper. And I wonder, how can you actually detect that there's a flaw in this function? Imagine a class with 10,000 lines of code. Can you know whether this code is actually vulnerable or not? So if your code is not maintainable, it's very hard to have an idea of how your security is. So because of that, and that's what we do, we have a tool that you can use to analyze your code. This tool provides you and guides you on writing better code. So that's why we call it the Better Code Hub. So we are promoting a contest for this, using this tool. So this tool is free of charge for certain, for all the GitHub repositories that are public, and up to a certain amount of lines of code. And you can use it to help you understand how your code is and the quality of your code. So if you enter the competition today and your code is one of the best rated, we also give you a free book that we wrote that helps you understand how to write better and maintainable code.